Okay, so let's begin with Kubernetes replica set, and we already discussed about this part of Kubernetes replica set. Now we'll do directly an example, and let's see. Same thing we do. I'll format this YAML file. I'll remove this image, and I will also explain you this YAML file. Replica set, replica set demo.yaml. So yeah, so first I explain you this YAML file, then we will do an example. Okay, so here's a certain set of details. So in the above code, API version is advanced beta version of Kubernetes, which support the concept of replica set. So this can be changed, in our case I think it is changed a bit. Okay, so yeah, this is API version, the kind is replica set. This is resource, we have defined the kind as replica set, which help kubectl to understand that a file is used to create a replica set. Okay, and tier is backend, we have defined the label as backend, which create matching selector, key, tier, operation, okay, in, and values is backend. This will help match expression to understand matching condition we have defined, and in the operation which is used by match label to find details. Okay, so we have this basic architecture like cube service, then we have got backend replica set, and we have three replica set I think. That's why no, here we have got three replica set. Okay, so yeah, as we mentioned that replica set is similar to the replication controller. There is a major difference between replica set and replication controller, that is that replication controller only support equality based selectors, whereas replica set support set based selector. Okay, so let's create replica set. I think I must do it like this: demo, replica set demo. Okay, just create it. Okay, let's assume that rs replica set tomcat replica set. Okay, let's see what happened. Okay, we have got three. I can do the same here, like if I delete it, if I make it like 5, let's make it 5, and let's delete it. Or delete it. Let's create it, and we have got 5. Okay, so we can also write describe, so we'll get more detail from this replica set, I think. Let's see. Oh, we've got more information. We have got 5 replicas, 5 pod status, 5 running. Okay, 0 waiting, 0 succeeded, 0 failed. Okay, so it is created. Okay. A selector is tier in backend. Okay, this is the name of the replica set. So here we did a small demo of replica set. Now we go explain a bit about small architecture, like cube is a cube service, and it has 3 backend replica set. And as I mentioned that it has 3 replicas here, that's why I created diagram like this. If I had 5 replica set, then I could have created 5 backend replica set. Okay, so yeah, we have got deployment. Okay, again I have some formatting issue, I apologize for it. So let's make it, yeah, now it looks not it still look not good. Okay, so I enlarge a bit. Okay, this look better. Okay, okay, yeah. So what is deployment? Deployment are upgraded and higher version of replication controller. They manage the deployment of replica set, which is also upgraded version of replication controller. Okay, so replica set is also upgraded version of replication controller, and deployment is also upgraded version of replication controller. Okay, they have capability to update replica set and are capable of rolling back to previous version. Okay, so we can update replica set and we can also roll back to the previous version. Okay, and they provide many updated feature of mesh label and selector. We have got a new controller in Kubernetes master called deployment controller, which make it happen. Okay, and it has capability to change deployment midway. So this is really a good feature because I don't want to redeploy everything if I deployed something incorrectly, and in midway if I'm able to redeploy it, then it would certainly save my time and effort, and obviously it will save my resources also. So this is one of the best feature of deployment. Okay, and yeah, changing deployment we have got okay, updating, deleting and rollback. Okay, so the user can update the ongoing deployment before it is completed. In this example, like existing deployment will be settled and new deployment will be created. Okay, so delete, user can pause, cancel deployment by deleting it before it is completed. Recreating the same deployment will resume it. We can roll back the deployment or deployment in progress. The user can create or update deployment by using deployment spec, pod template spec, or old replication controller pod template spec. Deployment strategies. So we have got some strategies to deploy. Deployment strategy help in defining how the new replication controller should replace the existing replication controller. RC stands for replication controller, I assume, because replica said we must write as RS. So yeah, so it help strategies help in defining how the new replication controller should replace the existing replication controller. How we can recreate, like this feature will kill all existing replication controller and then bring up the new one. This result in quick deployment, however it will result in downtime when old pods are down and new pods have not come up. This feature gradually bring up the old replication controller and bring up the new one. This result in slow deployment, and however there is no deployment. At all times few old pods and new pods are available in this process. So in rolling update we will gradually bring down the old replication controller and bring up the new one. This result in the slow, this process is slow. Okay, and all the time old pods and new pods are available. Okay, so this we can better understand with some example. Okay, so let's have a look at this deployment strategy, and then we have got this example. It is very simple. Okay, in the above code the only thing which is different from replica set is we have different kind of deployment. Okay, here we have a deployment file. So let's do this example. Oh. it is not bad, but it's really not good either. Okay, so create deployment. We can create deployment like this. This is deployment is also a resource in Kubernetes. Okay, so yeah, and we have got to execute these commands. Okay, so let's begin with the deployment. Yeah. Okay, deployment demo.yaml. Okay, no, I think I copied it incorrectly. So because something is wrong here, so I recopy it, repaste it. Yeah, now it seems quite better. Okay, so I execute the first command. Okay, so deployment.yaml, but here my is deployment demo.yaml. So first I did this kubectl create -f deployment demo.yaml. Let's compare it. Create. Okay. Let's see why it is record. Did I see somewhere record? No. Okay. Let's see what happened. This is created. Okay. Now I see what I deployed, like kubectl get deployment. Kubectl get deployments. Okay. Tomcat deployment. Yes, I can see it. I have got. I think I created 3 replica. That's why I'm seeing it like this. Okay. So 2 examples are done, and kubectl rollout status. Let's do this. Kubectl rollout status deployment tomcat. It is rolled out. Okay, now okay, let's see what is the image. What is the current image is tomcat container image tomcat 8.0. Now I copy this same thing, because if I write it I have to put extra effort. So oh, set image deployment. 1 minute. Yeah, here it is. Let's copy it. Yeah, I'm able to copy it well. So let's copy this thing here. Error. Deployment tabs. Deployment is not found. Yeah, there's a reason, because it is not correct deployment. So first is tomcat deployment. No, it is wrong. Again I will get an error. Let's see this, and it is updated. So this is updated. Okay, roll back, roll out, undo. Again tomcat deployment D. Okay, there is no need to specify type resource when passing argument. Okay, instead of get resource. Okay, I made a mistake actually, because if I write it like this, I create it like this. What happened? Okay. Hmm. Ah, so let's see. Get resource. There is no need to specify it. Okay. So now it is reverted back. Okay. So now we have like deployed our Kubernetes. We have rolled out. We updated its image. Let's see the describe. Yeah, that would give us a better picture of what we did exactly. Okay, so describe. Okay, so scale replica 0 to 3, 0 to 1, 3 to t. Okay, this is about scale down, scale up, and old replica set, new replica set. Let's see. Yeah, 6. See, we have updated our image, because here it is mentioned 8.0. You can see it, and here we have got 6.0. So it is updated. Yeah. So we are done with this example, and now we are heading towards volume. Okay, so what do you mean by volume, and how volume help us? That is a question. Okay. Again, this formatting is not good, but yeah, it is quite manageable. So let's go with the proceed with volume. Okay, in Kubernetes, a volume can be thought of as a directory which is accessible to container in a pod. Okay, we have different type of volume in Kubernetes. A type defined volume is created and its content. Concept of volume was present in Docker. However, only issue was that volume was very much limited to a particular pod. As soon as life of pod ended, the volume was also lost. On the other hand, volume that are created through Kubernetes is not limited to any container. It supports any or all container deployed inside the pod of Kubernetes. A key advantage of Kubernetes pod volume is it supports different kind of storage, wherein pod can use multiple can multiple of them at the same time. Okay, so first I draw some picture diagram. Let's see uh, what do you mean by volume here. I go here and then I draw X. This is the online tool available. Okay, so first of all, I don't need this. This is, I assume it is a pod. Okay, and inside it there is a container. This is a pod. This is a container. Okay, and then what happened? Directory. Okay, let's create a directory. Assume this is a directory. Okay, and it is also known as a volume, like okay. Now container. Oh, okay, sorry for this thing. Okay, so here we have a container has some data. Okay, and that data is stored here in the volume. Okay, but see, as most of you have worked with Docker, so Docker also has a volume, and that volume is different than the Kubernetes volume. Okay, in Kubernetes volume, it support different kind of storage, and in pod can use multiple of those volumes at the same time. And there is a one issue with the volume, the Docker volume. It is very much limited to the particular pod. As soon as pod life ended, volume was also lost. But Kubernetes volume is a bit different. Okay, that we will show you an example. We have different concepts in Kubernetes volume. So have a look at it. Okay, so we have different type of Kubernetes volume. Okay, I'll not go into all details. You can have a look at it. So like empty directory, empty dir. So it is a type of volume that is created when pod is first assigned to a node. Okay, it remains active as long as pod is running on that node. The volume is initially empty, and the container in the pod can read and write the file in empty dir volume. Once the pod is removed from node, the data in the empty dir is erased. Okay, the host path, the type of volume mount the file or directory from host node file system in your pod. GC is out of the scope, like it is just kind of a Kubernetes volume. You can have a look at it. It is for Google Compute Engine, and we are dealing with currently we are dealing with like Minikube. So yeah, it is a cloud-based Kubernetes volume, Google Cloud. Okay, this is Amazon cloud-based, AWS Elastic Block Store. Okay, NFS, yeah, it is quite helpful if we know about it. Okay. An NFS volume allow existing NFS network file system to be mounted on your pod. The data in an NFS volume is not erased. When pod is removed from the node, the volume is only unmounted. Okay, so ISCSI volume allow an existing ISCSI volume to be mounted in your pod. Flocker, it is an open source clustered container data volume manager. It is used for managing data volume. Flocker volume allow Flocker dataset to be mounted in a pod. If dataset does not exist in Flocker, then you first need to create it using Flocker API. So yeah, that is also beyond the scope of this tutorial. I'm just giving you overview. In case you are interested, you can have a look at Flocker API and how you can create dataset from Flocker API and mount it on your pod. Okay. And same is with Gluster, ERFS, open source network file system. There are some other kind of Kubernetes volume. Okay, now we go to persistent volume and persistent volume claim. So yeah, persistent volume, it is a piece of network storage that has been provisioned by administrator. It is a resource in cluster which is independent of any individual pod that uses persistent volume. Okay, and persistent volume claim is the storage requested by Kubernetes for its pod is known as PVC, persistent volume claim. User does not need to know underlying provisioning. The claim must be created in the same namespace where the pod is created. The claim must be created in the same namespace where pod is created. Okay, so these two features are really important. Like first, okay, I will go into detail of this thing, and we will certainly do an example to understand persistent volume in a better way. Okay, here we have got a persistent volume. So I just copied this example, format it, okay. Now I come here and pv demo.yaml and paste it like this. pv demo.yaml. It is already existing. Okay, so first I delete it because I already did some demo examples. That could be reason. So it is deleted. Now I create it. It is created. Okay, so this persistent volume is created. So let's go through some definition of persistent volume. Like its name is PV 3 times 0 and 1. Does it exist? Yes, it does. This is the name of this persistent volume. And what else? Here we define the capacity. In the spec we have capacity. We have capacity is 10 GI, okay, GB bytes, which is known as GI stands for GB bytes. Read write once. This tells exercise of volume that we are creating, and there is a path. Okay. Okay. So I created this file. Let's see. kubectl get pv. PV, and we got this information. Let's see what is here. PV 10001 10 GI read write once. RWO stands for read write once. Retain available. Okay. Then we describe this pod. PV 3 times 0 1. Okay, sorry, I made a mistake here. Okay, so we have got this thing PV001. This is a label, this is finalizer, and this is the path. Okay. Okay, now we are creating persistent volume claim. Okay, and we will also try to understand the difference between persistent volume claim and persistent volume. We discussed this thing before, like here. To be honest, I did not understand it very well. I don't think that you also understand it so well. Like it's a piece of network storage that has been provisioned by administrator. Okay, so it's a network storage provisioned by administrator. Okay, it is requested by Kubernetes for his pod. Like you are making a request for a particular storage. Okay, and user does not need to know the underlying provisioning. Okay, now understand it. So let's do one example with persistent volume claim. So I name it as pvc demo.yaml and put it like this. Okay, now here like we have what kind of resource it is. Persistent volume claim. It instructs the underlying infrastructure that we are trying to claim a specified amount of space. Okay, we are trying to claim a specified amount of space. Okay, now this is the name of claim, my claim -1. We could change it if we are comfortable with some other name. And this is access mode, like RWO, read write once. This specify the mode of claim that we are trying to create. Storage 3GI, this will tell Kubernetes about the amount of space we are trying to claim. Okay, so let's begin with an example. PVC demo. Okay. kubectl create PVC demo yel. It is this PVC is created, persistent volume claim, and then we get this thing. So here we have got a name of this persistent volume claim, my claim 1 3GI, read write once. Yes. Okay, then describe. Then we describe PV. Okay, let's see. PV 3 times 0 1. Let's see what happened. Okay, I made a mistake again. Okay, so I think I must not have written it like this because it is a PVC. So first I okay, so it is successfully provisioned. So here I must have written my claim 1. This is incorrect. Okay. Okay. So here we have defined our PVC and PV persistent volume and persistent volume claim. Okay. Now we are using PV persistent volume and persistent volume claim in the same pod. Okay, so I don't see. Okay, claim name is this. So it is using PVC, but so far I couldn't find PV. Let's see, persistent volume demo. Okay, so let's copy this thing, come here, fix it, then format this thing. This is a front end HTTP, and we are using image nginx image. Then we are volume, mounting volume here in this path. Then you've got a persistent volume claim. So here I have to specify PV and PVC pod demo.yaml, and we did this thing. Okay, so now okay, we have got this resource clear PV. Okay, so my pod is created. Describe, let's see, describe pod my pod. Let's see what happened here. Okay, we have got too many things here. Let's see. First is we have got container id, its image is nginx, container is creating. Okay, condition like pod ready to start containers. Okay, volumes, my pt persistent volume claim is the same name space, this is a claim. Okay, if that claim is not created, then I will certainly have error. Okay, so it's important to create claim first and then create this resource. And here we have got a config map. We will certainly discuss config map. It is one of the important part in Kubernetes, but maybe in next video. Okay. Okay, so far we are done with this, and we are good to go with Kubernetes secret. Okay. So secrets are very important. What is secret? First we discuss this thing. Secret can be defined as a Kubernetes object and used to store sensitive information such as password, username, password with encryption. We can also consider storing token, API keys, username and password in secrets. Okay, we can either create text file or either YAML file. Okay, so creating from text file, in order to create secret from text file such as username, password, we first need to store them in text file and use the following command. What is the following command? This is the following command. Okay, kubectl create generic tomcat pass from this. Okay, so this is what we have to do now.